That's me, a few years ago. And that's Baxter, the robot I'm doing my PhD with. Differences between humans and robots: cognition, emotion, and also movement. From a young age, we learn how to control our body in ways no robot has yet achieved. Robots have very limited movements. Their brains, what we call controllers, can be designed to perform with great accuracy a specific task in a specific environment. But if any of those conditions changes, the controller is then useless. It's as if every time you wanted to do something new, you had to replace your brain with another one specifically designed for that. Not cool. Our brain, together with other nervous regions such as the spinal cord or the cerebellum, keep this one in mind, allows us to learn new movements and to adapt to new situations. The goal of my thesis is to give robots, like Baxter, motor capabilities similar to those that biology has given us. So, let's take inspiration from biology. Why don't we make an artificial copy of our brain and use it for robot control? Well, we just don't know enough about the brain yet to make such an artificial copy. But the cerebellum, now, that's a different story. It is a nervous region located at the back of our head, and it plays a key role in motor learning and coordination. If you are playing tennis and you hit the ball too hard, the cerebellum learns how to correct the difference between what you wanted to do and what you actually did. And neuroscience has provided a clear enough picture of the structure of the cerebellum and how it works. My thesis focuses on developing an artificial cerebellum for robot control. Using artificial neural networks, just a fancy way of saying mathematical equations and programming code, we replicate the structure of the cerebellum, from single neurons to the connections they make. We also replicate the biological mechanisms that allow those connections to change based on experience, what's called synaptic plasticity, the key for learning. We run the artificial cerebellum in a computer and connect it to Baxter. Just like we learn how to control our muscles to ride a bike, Baxter can now learn, through trial and error, how to control the motors of the arms to do different movements. And while doing so, Baxter can also adapt to new situations, like handling an additional payload, just like we can. My thesis is an example of how neuroscience and robotics can benefit each other. Neuroscience can inspire the development of more advanced robots, not to create the Terminator, but to have robots as tools that can help us in performing demanding physical tasks or in exploring dangerous places. But not only that, these robots, equipped with replicas of our nervous system, can repay the favor to neuroscience and be used as guinea pigs to study how the brain works, neurological disorders, and even possible treatments, so that we can understand and take care of what makes us human. Thank you.
You may be asking yourselves, why do I have a picture of a toilet behind me? Well, did you know that every time we go to the toilet, 90% of the man-made medications we use are scattered into the ecosystem through our very own excretions? These contain harmful toxins that travel from your laboratory to a water treatment plant, from where they produce a nasty, horrible sludge. This is later composted and applied to soil. Yes, the very place we grew our food, just like these apples. But you wouldn't want to eat one, would you? Sadly, if we don't do anything, these compounds will forever remain in the earth, contaminating future food, future apples, for future generations. My PhD focuses on improving this composting process to ensure that this doesn't happen, and so that you, me, and our children's children can eat that apple. This was done with the brand new technique I developed with a little help from some little friends. They are here right now, but don't look around because we can't see them. I'm talking about microorganisms. These tiny little helpers were living naturally in the compost, where they showed extraordinary mechanisms to eliminate pharmaceutical compounds. The problem was that there weren't enough of them. To make this clearer, let's imagine that I give you a massive burger, but you only have 20 seconds to finish it. Sounds impossible, right? But what if we all shared it? It'd be much easier, wouldn't it? Well, this is exactly what I did with my microorganisms. First, I grew them in the lab under optimal conditions. And then I added them to large quantities of compost at frequent intervals to increase their amount. As a result, the concentration of the drug residue in the final compost had been significantly reduced, But not only that, the microorganisms had also improved the nutritional value of the compost, making it an even better fertilizer than before. What's more, this method is a completely natural process, which is also flexible, scalable, and cost-effective. And if using microorganisms makes some of you feel a bit uneasy, don't worry. I've also proved that it is neither toxic nor has any harmful side effects. In this way, having as many microorganisms as there are pollutants in the world, by using them correctly and efficiently, we'll not only be able to cure our own illnesses, but to look after the earth as well. So, would you like to eat that apple now? Thank you.
I suppose you all know the character on the slide. For those of you who don't, it's Homer Simpson, a well-known fictional character. Homer is a clear representation of today's society. He has a job, a wife, and children. But he's also known for his love of donuts. This representation is true to life because he, like society, doesn't do any physical exercise and eats a diet based on sweets, pre-cooked and ultra-processed foods, which you only have to heat up in the microwave to eat. In short, foods high in sugar, fats and calories. So Homer suffers from being overweight or obesity. It has been observed that since 1975, the prevalence of obesity has tripled, with 40% of the world's population being overweight and 13% being obese. So it is a serious problem, and it could be said that obesity is the chosen pandemic, since we had created it and in the vast majority of cases it is avoidable, simply following a healthy diet and doing some physical activity. One day my mother asked me, "Alex, why don't you invent a pill that will make you lose weight and be healthy?" Well, that is exactly what my thesis is about. My objective is to create a drug based on natural extract to treat obesity. What is a natural extract, you may be wondering? It is nothing more than extracting the compounds of interest of a plant and placing them in a medium, such as water. And what are my extracts made of? Well, they are exactly what humans has always fed on: legumes and vegetables. But what is even more interesting is that I don't extract them from the plant itself, but from its seeds, which are often a waste product. For example, when you eat a watermelon, the seeds are usually discarded, unless you prefer to eat them, which some people do. So we try to put them to another use. However, for Homer, the story was not going to be so pretty, because I also studied the effect on this drug together with physical exercise, and he doesn't like that so much. To be more precise, I studied high-intensity interval training, a type of exercise based on performing short bursts of intense activity, resting and repeating it a couple of times more. An example would be running for 30 seconds, walking for 1 minute, and repeating it 5 times. So, given today's high fast-paced lifestyle, my thesis could be used to study if it's possible to improve people's health by just taking a pill and doing 15 minutes of sport a day. Thank you.
Our world is changing fast. We've rapidly gone from being nomadic to sedentary people. And everyone has noticed this except our brain, which has changed very little over time. As an experimental psychologist, I know how important it is to study our brain's reaction to our ever-changing environment, so we can adjust the environment to meet our brain's needs. For example, one mechanism that we still have, which has been very useful to us over many centuries, is distraction. When we were hunters, our brain needed to be aware of every single detail around us, and our ability to become distracted eventually saved us from the tiger hiding behind a bush. But now, although we don't need to be aware of the tiger, we still have this mechanism. Well, when studying distraction, we try to reproduce everyday situation in the lab, measuring participants' behavior, mistakes, or brain electrical activity. And what we observed is that sometimes distraction can actually be avoided, but only when we are engaged in a very complicated task. So, how does this translate to our environment? Well, it means that if we are focused on reading the news on our mobile, we wouldn't get distracted by street noise. However, these noise are outside of our mobile and outside of our focus. And if you think about it, society has led us to have everything on the same screen, both our work and our social life. In other words, the things we have to do and what distracts us from that. So, the question of my thesis is, can we still avoid distraction when it comes from the same place we are actually focusing on? Well, what we discovered is that we can easily avoid being distracted by what's outside of our focus. But when it's within our focus, within our screen, it does not only distract us, but it also constantly interferes with what we are doing. Our brain takes much longer to get back to it, and when it does, it usually makes a lot of mistakes. In other words, if we are reading the news on our mobile and we get a WhatsApp message, this will definitely interfere with our reading. So I'm sure that this sounds familiar to you, but remember that it's not our brain's fault if it keeps trying to save us from the tiger. Rather, the changes in our environment that are ignoring the effect they have on us and on our brain. Right now, our society is facing a new kind of tiger, and understanding the effect that it has on us is the starting point to save ourselves from this tiger in the future. Thank you.
With my thesis, I am going to explain how a simple mathematical operation such as 1 + 1 = 2 does not apply to bilingualism. When we think about a bilingual, we tend to imagine somebody who speaks 2 languages perfectly. However, that is not the norm, and it should not be taken as the gold standard. Bilingualism should be rather understood as a continuum. It's more a question of the different shades of grey than a black or white option. And speaking of bilinguals, let me tell you a brief story about myself, which motivated my research. 8 years ago, I moved to Wales as an Erasmus student for my year abroad, and as time went by, I gradually realised that my English was getting way better. But when I came back to Spain, to my surprise, my friends told me that my Spanish was rubbish. Now, how was that even possible? Well, it has been shown that the 2 languages of a bilingual are in constant interaction in their brains. They influence each other. So not only did my first language, Spanish, influence English when I spoke, English was also active when I spoke Spanish, and that is the main aim of my research. In my thesis, I'm investigating how Spanish-English bilinguals use, interpret, and comprehend their first language as influenced by their second language, both when they live in an English-speaking country like the UK, but also as the novelty of this thesis when they live in Spain. And among the many things that we could explore within language, I am particularly interested in linguistic ambiguity. So just think about the following sentence for a second. Shakespeare saw Cervantes while he was opening the door. If I asked you who was opening the door, then an English native speaker would probably say that it was Shakespeare who opened the door. By contrast, a Spanish native speaker would believe it was Cervantes who opened the door. And no, this is not because we favour our own literature. These reflect general interpretation preferences in each language. But curiously enough, these preferences are not stable. They change in bilinguals, and this is what our results show. It's only when we treat bilingualism as a continuum that we see that the more we use the second language, the more we are exposed to it, but also the more positively we think about it, the more likely our first language is to change. And interestingly, this can also happen if you are in a non-English speaking country like Spain. So this flexibility of our first language is essential since it has been linked to successful second language acquisition. So the next time we think about somebody who's learning a second language, the result will never be the sum of 2 monolinguals in just one brain. 1 + 1 will not equal 2 this time around. The result will be something far more complex and unpredictable, which I invite you to explore for yourselves, since it will open many and open doors which I'm sure neither Shakespeare nor Cervantes would be able to open for you. Thank you.
Did you know that our brain sends electrical impulses through our body? Actually, our muscles work thanks to these electrical impulses. Much of the knowledge in this field we attribute to Santiago Ramón y Cajal, a famous Spanish scientist who won the Nobel Prize when he took a picture of a neuron and showed it to all his colleagues. It was soon proved that the cells he discovered in 1906 were responsible of carrying this electrical impulse right from our brain to our muscles in order to activate them. Such a process seems to be even more important in today's society, which appears to be rather sedentary. A sedentary lifestyle is characterized by low physical activity throughout the day, which in the long run it may lead to obesity and cardiovascular diseases. Bearing in mind the current levels of obesity, there is a real danger for us, our relatives and colleagues. And in my thesis, I want to discover if electrostimulation would help in this process. As a researcher like Ramón y Cajal, I remember my excitement about the idea of improving people's life through exercise, but not only the healthy ones, also the ones who are sick. And in this sense, the electrostimulation applied through the suit that you can see appears to improve the quality of life of people by bringing the same electrical impulse to our muscles. Apparently, it seems that we have the power to activate our muscles through an artificial application and improve people's health. So far, in my thesis, we have seen that electrostimulation increases energy expenditure by 600% in bedridden people. And we have also found that it has almost the same effect as walking. Can you imagine how people who are unable to move would feel if they could reap the benefits of walking? However, we haven't seen that electrostimulation increases muscular strength after a bodyweight training plan. Yet, what we did observe is that the use of electrostimulation as a warm-up can improve squat performance. Finally, one of the great milestones of electrostimulation that interests me the most is whether this tool can help hospitalized people, people with reduced mobility, or people who had a stroke. When we manage to answer this question, we'll be able to help people like my father, who had recently suffered a stroke, to achieve the levels of physical activity necessary for good health. I'm truly passionate about discovering how electrostimulation would help this kind of people, and finally, to help my father remain active despite being confined in a wheelchair. Thank you so much.
Are you familiar with the pictures or signs we get everywhere that say home or home is where the heart is? I'm sure you are, aren't you? I believe that these phrases show that it's become quite complicated and confusing to define what exactly our home is. It's like we have to plant a flag as if landing on the moon. So in my field of research, which mainly deals with studying literature in English from a gender perspective, for years now, they've been studying the type of literature that is created in this context. That's to say, when our home is hard to define. And, as you know, our home is key to defining our identity. This is the way post-colonial literature originated, where authors didn't fully identify with their parents or the colonizers' cultures. And by the way, how do we define our identity? Yes, we define it through the stories we tell about ourselves and others. We are the great narrators of our own identities. With the passing of time, the world's become more globalized. So in my thesis, I'm studying transnational literature. This kind of writing is emerging today, and it shows that crossing borders can create complex identities. This type of literature can talk directly about migration, but we could also think of it as transnational because the authors themselves have crossed borders. So what do I do with all this? My aim is to see how transnational women authors create their identities through their writing. I mean, are they more connected to their roots or the roots they have followed in their lives? Is there any similarity or common pattern in their works? To do this, I'm carrying out a careful feminist analysis of short stories in English. Luckily for us, the readers, we can come across stories like Treasure, where the protagonist uses this fake name on social media in a society with a great social gap. Or take the story called Wild, in which a mother thinks her teenage daughter is becoming wild, growing up fatherless in the US, and so the girl is sent back to Nigeria. I know you probably haven't joined the dots yet. However, the strongest link that I have found among the stories is that they all make us reflect on a fairer society. Getting to know people we think are different from us is key to understanding each other better. And as we are going global and this type of literature is growing, I'll also make a teaching proposal following responsible pedagogy. Yes, because I'm convinced that it's everyone's responsibility to create a more diverse and inclusive society with equal opportunities for all. Thank you.
What would you think if I told you I had a little bottle of gold particles and then I threw half of it away on purpose? That I'm crazy, right? Gold is far too valuable to throw away senselessly, isn't it? Well, this is more or less what happens in hospitals with the medicines I research. They are extremely expensive and part of their content usually ends up in the bin. But instead of gold particles, we actually have therapeutic monoclonal antibodies. Now, what exactly are they? Monoclonal antibodies are proteins we call biotechnological medicines, which are so expensive because they're produced using living cells and complex techniques. These innovative therapies are currently used for the treatment of different diseases, such as cancer. Most consumption of these medicines takes place in hospitals, mainly because they're measured out according to the patient's weight. However, once the medicine bottle is opened to take the necessary amount, its shelf life is very limited, in many cases only 24 hours. So the leftover medicine is just thrown away, which has a serious economic impact on health systems. Here's an example. For my PhD, I'm examining nivolumab, which is a monoclonal antibody used to treat lung cancer. The full treatment of a single patient costs around 30,000 euros. So if a patient only needs half of the medicine in its dosage, the other half would be like throwing gold away, wouldn't it? But might it be possible to use leftover medicine beyond its recommended date of use? This is one of the questions my thesis is trying to address. And to this end, I'm studying up to how long this surplus medicine can safely be used. The problem, though, isn't only the price, but also the fact that these proteins are easily degraded. This means their structure can undergo certain changes because of routine handling in hospitals, which affect their safety and efficacy. Now, what are the factors that bring about these changes? For instance, some of the results I've already obtained from nivolumab show that it undergoes a few structural changes when exposed to sunlight. So we recommend handling it while protected from the light. As you can see, my research provides recommendations on the proper handling of these medicines, and also an answer to the possible reuse of their surplus. In this way, they can reach more patients and in turn reduce hospital pharmaceutical expenditure, because it makes absolutely no sense to throw gold away. Thank you.